Hello everyone. I hope you are doing well given the circumstances with the coronavirus. First, I would like to thank the organization committee as well as the reviewers for allowing this event to happen, as well as my supervisors Mauro from Telecom Paris and Xiao from BNP Paribas. My name is Atouati and I am a PhD student at Telecom Paris in collaboration with BNP Paribas from France. To introduce our work, I would first like to say that people live through various types of experiences. They travel abroad, they eat at restaurants, they play paintball, they go to discotheques, and as social media became more and more prominent and ingrained in our daily lives, people tend to share their opinions and experience in social media all the more, both the good ones and the bad ones, especially the very, very bad ones. And from the various types of social posts available, one in particular piqued our interest, and that is negative purchase intent. We mean by that a user expresses his unwillingness to consume from a company in the future. The main question is, can we predict or identify negative purchase intent reliably? Before diving into the meat of the matter, we will first present our motivation. So, raw purchase intent, as in positive purchase intent, the willingness to buy or to consume, has already been studied before, but its negative counterpart has never been studied before. Second, negative purchase intent can be expressed with a wide variety of vocabulary, including hashtags, sarcasm, and metaphors. The lack of labeled data regarding this problem also poses a tough challenge. And finally, this problem finds relevant use cases in brand reputation, crisis management, as well as uncovering potential investment opportunities that are still untapped. Now, the first question that comes to mind is whether negative purchase intent is the same as negative sentiment. The short answer is no. As for the long answer, there are many tweets where people express negative purchase intent without a mention of negative sentiment, whereas there are others where people express negative sentiment without a mention of negative purchase intent. To perform the study in a quantitative way, we computed the correlation between the negative purchase intent label and the Vader aggregate sentiment of our tweets and found only a correlation of minus 0.15. Although the sign follows the intuition, it shows that negative purchase intent is not explained away by negative sentiment. Another question is, which scandals are more likely to spark such an extreme reaction the most? In our study, we are interested in British Airways. British Airways is a commercial flight company based in the UK, which is part of the conglomerate International Airlines Group. British Airways suffered from two scandals consecutively in 2018. The first was a racism scandal, and the second was a cybersecurity one. The first one was the deplaning of an Indian family by the boarding staff because their child was crying. The second, the cybersecurity breach, involved the death of more than 400,000 customers' credit cards data. More formally, we define negative purchase intent as the expression by the user of the willingness not to consume or buy a product or service from a given company in the future. As you can see through our example, we can have negative sentiment paired with negative purchase intent. We can also have positive sentiment paired with negative purchase intent, as in the inability to buy being the cause of the negative purchase intent. We can also have the same for positive purchase intent. positive purchase intent with negative sentiment by necessity, and negative purchase intent and positive sentiment with positive purchase intent as a natural expression of enjoyment of the product or service. For data collection, we use the simple query British Airways to retrieve data from Twitter. We have a first set, which ranges from August 1st, 2018 to November 1st of the same year, which we use for model building and evaluation. And the second period ranges from January 1st to July 31st of the same year, which we use for a sampling evaluation. Regarding the labeling, we pre-selected tweets based on consumption-related keywords for the airline business. We then used this set as a base to which we completed with randomly selected tweets from the rest of the model building set, meaning the set ranging from August 1st to November 1st. Next, we give instructions to volunteers so that they label this data, and we finally obtain around 12,000 tweets with around 12% of negative purchase intent. So, first we start with the pre-processing. We remove stop words and punctuation. We also perform lowercasing. We lemmatized all the words. We don't perform stemming, however, because stemming would lose the information contained in the part of speech nature of the word. We want a verb to remain a verb, an adverb to remain an adverb, etc., as it is important later on. Next, we perform hashtag decomposition, as we found that frequently enough, negative purchase intent was expressed in hashtags rather than in the text of the tweet. Now moving on to feature selection, we select feature words based on a modification of the conditional probability. In the literature, pointwise mutual information is often used to select features in natural language processing tasks. Knowing that it is an increasing function of the conditional probability of the class of the tweet knowing a word that appears in it, we compute a confidence lower bound score on this conditional probability as our criterion for selecting keywords. We rank these words according to this lower bound confidence score because it allows us to penalize word rarity, which may be problematic later on for our model. For the representation, we build keyword windows centered around verbs and adverbs. We choose verbs and adverbs as our central part of speeches because they are necessary in negative purchase intent expression. Next, we build for each word window, we build the one-hot encoding based on the previously selected feature words. This yields a matrix representation for every tweet, where the number of rows is the number of neighborhoods and the number of columns is the number of feature words pre-selected. For each neighborhood, we compute a logistic score, of course based on the same weights, and then we select the maximum of these logistic scores as our output probability, which we fit using gradient descent in order to minimize the betas. Now, this follows the intuition that negative purchase intent is a localized information. If negative purchase intent is expressed anywhere in the tweet, it would be localized in a specific neighborhood. Or, in other words, some neighborhood is bound to contain it. To summarize our approach, we start with the pre-processing step, followed by a feature word selection. Next, we perform a neighborhood representation of our data using a part of speech guided window selection. Then we use a max pooling of neighborhood logistics scores. Our approach can also be thought of as a convolutional neural network, although a simple one, but which convolution zones are defined not by a stride, but by a part of speech. In terms of evaluation, we use tenfold cross-validation evaluation for the model building set from which we extracted the data we labeled. We compare our approach with two approaches previously used to study raw purchase intent. The first one relied on pattern matching, while the second one relied on an SVM over a rich set of features containing both linguistic ones and sentimental ones. We also compare our approach with LSTM and BERT. Under an equivalent training time constraint, our approach outperforms all the rest in terms of F1 score, whereas BERT would work better than our approach if allowed to train for more than 5 hours. We also compare our approach with other logistic-based methods involving eventually word embedding in Word2Vec. We use both Word2Vecs, BERT the pre-trained version and a custom-trained version on our whole data, and we find out that we outperform all logistic-based methods. For more details on these, please look at the paper. For the sampling evaluation, we trained the model on the fully labeled data, and then we labeled all the data from January 1st to July 31st. Then we sampled 300 tweets labeled as negative purchase intent from this data, and 300 tweets labeled as non-negative purchase intent. Using a wrong but simplifying assumption, we evaluate a lower bound on precision and recall, which gives us an idea on the real quote-unquote out-of-sample performance of our approach, which seems to be satisfactory. So now, what does this model tell us about people? Using our model in the 3-month period surrounding the cybersecurity scandal of British Airways, we find that negative purchase intent is spiked during both scandals. However, the racism scandal yields a much more bigger spike in negative purchase intent than the cybersecurity breach. In conclusion, our contributions are the definition and study of negative purchase intent, the development on an approach that outperforms state-of-the-art under training time constraints, as well as providing preliminary results on which events spark negative purchase intent the most. Regarding future work, we consider extending our approach to other data sources such as Reddit, blogs, other companies and sectors, and also more scandal-rich periods in order to generalize more the findings that we had or refute them eventually. Look for more efficient models under training time constraints is also a possibility, and the most interesting direction of research is looking for insight into brand management and financial consequences. I hope you stay safe. I thank you for your attention, and that's all, folks.